Crystal field theory. The important points of the crystal field theory are following. The attraction between the central metallic atom and ligands in the complex are negligible. The central metallic atom in the complex is regarded as a positive ion of charge equal to the oxidation state. There is a repulsion force between electron on central metal and ligands. Thus, the electrons occupy the d orbitals farthest away from the direction of approach of ligands. Ligands are considered as a point charge. In the formation of complex, d orbitals are split into the different energy levels. The main limitations of crystal field theory are following. The assumption that ligands are point charges is not practically true because anionic ligands should have strong field, but actually many of them are not. It does not take into account the covalent character of bonding between the ligand and the central atom. Crystal field splitting of d orbitals. The 5 d orbitals can be classified into two sets. 3 of d orbitals which are oriented in between the coordinate axes are called T2g orbitals. The other 2 d orbitals oriented along the axis are called Eg orbitals. In the case of free metal ions, all the 5 d orbitals have equal energy, but their interactions form one pair of ligands and their energies also become deficit. This splitting of 5 d orbitals of metal ions under the influence of approaching ligands is called crystal field splitting. It is denoted by delta and is called crystal field splitting energy. The ligands which cause greater crystal field splitting are termed as strong ligands, while those which cause lesser crystal field splitting are weak ligands. Crystal field splitting in octahedral and tetrahedral complexes. In octahedral complexes, the 6 ligands approach the central metal ion along the coordinate axis is the axis dx2-y2 and dz2 orbitals. The set of orbitals has higher energy than T2g of orbitals. In tetrahedral complex, 4 ligands may be imagined to occupy the alternate corners of the cube and the center ion at the center of the cube. In this situation, the T2g set of orbital lie relatively nearer to the approaching ligands, and therefore T2g set of d orbitals have higher energy than Eg set of orbitals. The relationship between delta T and delta O is given by delta T is equal to 4 by 9 delta O.